Dear students, welcome to the problem solving session on paired t-test. We learn all the basics on t-test in our previous videos. So t-test is classified into two types. One is paired t-test, the other one is unpaired t-test. Here in unpaired t-test, the samples are independent. So I can compare with different samples. But in the case of paired t-test, the samples are dependent because you are taking the blood samples of a patient. Suppose you're checking the diabetes. When you check the diabetes, I have to take the blood samples of 10 patients. Then after giving the medicine, after 2 hours or 3 hours, I have to check the blood samples of the same patient. Here you cannot change the patients. But in the unpaired test, two independent groups, group A, group B, will be verified for different kinds of data. Here in paired t test, group is same, only my time is going to differ. I'll check the blood sugar level at 8 a.m., 9 a.m., 10 a.m., 12 p.m., 3 p.m., 4 p.m., etc. etc. So paired samples, they are dependent samples. Whenever we are going to write H naught, I am going to check is there any difference between the same samples with different time. So for the first time I will take this as X and the other time I am taking it as Y, and I'm going to find the difference between X and Y. So H naught will say there is no difference in the average. So we are going to take mu D equal to 0. That is, there is no difference between the population means at different time. The formula for T statistic is D bar divided by S by square root of n minus 1. For the unpaired T test, we use the formula x bar minus mu divided by S divided by square root of n minus 1. Here we are taking the same sample. So my D is x minus y and D bar is summation D divided by n. You know how to find D. As usual, degree of freedom is going to be n minus 1 because we have only one group of data. Now to find S, we have to use the standard deviation formula summation d square by n minus summation d by n whole square. This is the standard formula. Since we already found d bar, that is summation d by n, so I can rewrite this formula as summation d square by n minus d bar whole square. Both are correct. You can use whatever you like. As usual, we can write the conclusion. If table value is bigger than calculated value, then say H not accepted. If table value is greater than, if table value is less than calculated value, then H naught is rejected. How to identify whether the problem is paired t-test or unpaired t-test? Read the question. The memory capacity of student tested before and after. So the student group is same. They are checking before and after a training. So very easy. Before training, how they are. After training, how their behavior are. So data is same, only time is getting deferred. So it is paired t-test. Obviously we can tell this. And very important, this is the label of the student. First student, second student, third student, etc. We should not consider this. This is simply the label. The data are here. And one more trick in paired t-test, when we compare before and after, so either my knowledge will improve. If suppose there is a disease, then the disease will be getting reduced. You are getting healthy. So it is going to be one tail test for paired t-test, almost all the cases. So let us write, we have only one data here. Don't think this is two data. For the same 9 students, we are taking the data collection before and after coaching or training. Null hypothesis always say from this sample for the whole population there is no difference. H1 we have to tell after coaching. I will not say that my knowledge will reduce. The student's skill and knowledge will improve after doing coaching. Next we have to find H1. X is before training and Y is after training. So X minus Y should be less than 0 because after training there is an improvement. So we can say mu D should be less than 0 because after training there should be a big change in the students. So my population mean should be less than 0 when you take the difference between X and Y because Y is the improved part. So it is one tail test, alpha 5%. Here we should be very careful at 5% level, degree of freedom n minus 1, that is going to be 9 minus 1, 8. Since it is one tail test, I should not take the 5% level values in the table. We have to see 10% level values in the table because it is one tail test, but my two tail test table is given in the exam. So we have to see at 10%. So let us see the table. My degree of freedom is 8. Now we should not see 5%. We have to see 10%, that is 1.86. Therefore, my T alpha value is 1.86. Next, we have to fill the table and we have to find D bar S to find the value of T. So let us fill the label. This is not necessary. Now, the data given before coaching and the data given after coaching, we have to fill one by one. Now we have to subtract before and after. There comes a question some students may ask, sir, why can't I do this? Y minus x. You can do because at the end I am going to square this. When I square this, either y minus x whole square or x minus y whole square, they are going to be the same. So no issues. Now subtracting 10 minus 12, it is minus 2. Next one is minus 2. Like that, we have to fill this column. And now we have to square this d and write the data here, and finally we have to add everything to get summation d square. My summation d square is 29, and we have to add summation d also. It may be negative, it doesn't matter. We have minus 7. So d bar is summation d by n, that is minus 7 by 9, minus 0.778. Next, standard deviation summation d square by n minus d bar whole square. Just now we found summation d square is 29 divided by n minus of minus 0.778 whole square. So use your calculator, find the value. The value is 1.618. Now we have to apply this in our formula. D bar divided by S by square root of n minus 1. Use your calculator, find the t value, take the modulus. Modulus of t is 1.360. Now we have to compare with our table value. My table value is 1.860 and calculated value is 1.618. So my calculated value is less than table value. Very obvious. H0 is accepted. So before and after training, there is no change among these two groups. They are not effective. We have to change for a new training group. Hope you understand, students.